All right, let's get the voice checking happening. Good evening, all. How's it going? 900 channel points. Wow. Rip. How am I sounding? And that is not your cue to take a cheap shot at my voice. Hopefully, 4K, jeez. So, greetings to everyone. Archbishop, Multi, Asaf, and whoever else who is sitting there raring to go but hasn't said hello. Serializing! Welcome back. Good to see you again, sir. Okay, I think everything, all my dials and everything are looking good. So, let's get the show on the road. Hey, Benzie! How you going? You're not showering or lifting weights. Have a guess what I'm doing instead. Watching me do a terrible job of writing code. No? Yes. Sitting on the couch, doing nothing, drinking tea, watching live streams. Speaking of tea. Again, this light makes it look really pale. Probably should work. I need to get one of those lights that actually makes me look non-terrible. Yeah. Ah, Rasta's subbed again. Thank you, Rasta. You are a legend. I appreciate your support. Good evening, Civilized. Good evening, Ben. Good evening, Sisop. How are you all doing? Massaging the wife. You are earning good points there, my friend. Well done. Well done. Hacking without tea is very uncivilized, so make sure you have tea. Or, you know, if you must have non-tea, your beverage of choice. That's fine. That's fine too. It is a child-friendly chat, yes. Hello, Adwolf. White shirt instead of spark. Yeah, I know. I was noticed there's a little bit of sparkle going on the right arm here. But tell you what, every time I put a different shirt on, the sparkles change. So I just kind of given up on it. But I'm hoping that once I get one of those backlights that lights up from the front, I can tweak the color thing so there's not as much green in the fingers when I do stuff like that, and I don't get the sparkles. Hello, Rasta. You do need some tea for the hacks, although haxing, deving of the haxing utilities. Beat Saber tune. I love this song. It's a great song. Okay. Does everyone remember where we left off? Yeah, I've streamed to this song before, and it's a good thing you didn't see me on camera because I was drenched in sweat. Displaying songs. Oh, is it? Yes, it would appear so. But if you have a look at that way, up there at the top of the chat, my finger's going to run out of space. You'll see it at the top of the stream. Yeah, it didn't post a song. I don't know what's going on. I'll have to reconfigure Moobot, although apparently Moobot is currently on stream, so I don't know what's going on. Anyway, this is really hard to do on Expert Plus if you're a Beat Saber fan. We are doing more channels today, Rasta. Yes, we are. The plan is... yeah, I hear you, man. Sorry about that. Yeah, so the plan today is to get as close as possible to having, if not completely finishing, the TCP client version of the channel so that we can get NC comms going through our port forward. Hey, Athuli, how you going? Oh, tea's good. No chocolate tonight. I'm being a good boy again. I've been doing the push-up challenge and I kind of feel like if I have too much chocolate, then I'm, you know, I'm unwinding all the effort that I've put in. All right, let's jump to and go back to where we were before. Web stuff, hey? Something weird going on locally, breaking the stream, having to tether. Well, nothing at this side has changed, so yeah. Did I see the lame C2 or you dropped? No, I didn't see that. Did you tweet about that? I haven't been looking at the twits as much as I usually do, so you might have to share that in the link below Link below, Rasta. Everyone pay attention. Rust is about to drop a link to some cursed C2. Hey, CC2. C22. There you go. There's the blog. Sharp 2. I wonder if that implies what it's written. Bet it does. Okay. I'm going to bring my VM up so I can see it. Go have a look at Rust Mouse's work. See if you can abuse it to your own, for your own means. Okay, so where we got to last time, as you can see, I haven't touched this VM since. We got to a point where Metasploit believed that we had a valid standard API net TCP client channel established with our Meterpreter session. Of course, that was a filthy lie because we had created a channel object behind the scenes, but we weren't doing anything at all with it. So what we're going to do today is we're going to start managing channels. We're going to start shuffling data back and forth on the socket in an asynchronous fashion. And we are going to hopefully get to a point where the manager in charge of the channels is able to intersect with those communications and kill it off. Okay, so that's basically the plan. Any questions thus far before we get started? Yes, yes. Well, you know, the good thing is there's now going to be another open source implementation of channel management. So feel free to send a link to the repo to Foxtel. That hat is great, Archbishop. Love it. I should get one in real life and actually appear on stream with sombrero. Alright, so let's go back over here. So this is where we were at last time. As you can see, we had created this new channel. We should probably check to make sure that the channel itself has been created. Alright, so let's get rid of breakpoints. I'm going to assume for now that those people out there who have this on stream can see the size of the text. I had to adjust it last time. Hello, Command Control. Welcome. Do you know how to hack? Yep, that's right. Get rid of him. Out. Go home. Boot the boy. Alright, so what we'll do here is we're just going to make sure that the new channel exists. So if it doesn't equal null, then we'll go through the pain of saying we'll manage it. So obviously the channel manager is going to need to keep track of stuff. And that stuff, I think we can just use as a map from the channel identifier through to the implementation of the channel. I don't think that's unreasonable, right? So let's just, first of all, we should mark this as private. Channel creator. So we're going to have a private dictionary of, now we know that the channel identifier is a, what was it? Channel ID is a uint. So we will go uint to channel. We'll call them active channels for now. Right? Okay, this start active channels, new channel. Okay, so if the channel's null, not null, then we'll go active channels. Now we know that the channel identifier is going to be unique for the channel, so we should be able to add it at this point, right? Equals channel. Oops, new channel. Okay, so now we're technically managing it, right? At which point we should be able, should be able to like pass stuff back and forth to and slash from it. Okay. So what we'll have with our packet dispatcher, like when we actually send data down the channel, we'll need to know exactly what that is. So I don't know whether there's going to be a core channel write call or a core channel read. I assume that when we've established a connection on the Meterp side, as a result of the action on the Metasploit side, then it'll be sitting there and we'll get a write to the channel from the client. So we will need to handle that scenario. Hello, Bitwise. Welcome to the stream. Good to see you again. Now, again, please feel free to ask questions along the way. Mugu, welcome. Good to see you again, Suso. I hope all is well and that you're all COVID-free. Thank you for cheering. Hooray for Mugu. Okay, so let's just quickly build that. That should result in... oh, what is this? Ah, yeah, that's me just being lazy in debug mode, so that's fine. So what I'm going to do now is we're going to establish the connection and we're going to persist the channel, and then what we're going to do on the client side is try to send data and see if any command comes in that we are not aware of. So in order to do that, we need to look at the... where is it? Basically where we handle, get commands for extension. Invoke handler, I believe, is what we are looking for. So when we get a packet, we want to invoke the handler, and then if we don't, we want to go call not implemented. So let's set a breakpoint here. Rasta Mouse, what are you doing? Wow, thank you very much, Rasta. You are a legend, my friend. That is very kind of you. Gifting subs to the peeps. Binchuk, Alasawe, Benzies, Asaf, and Bitwise, you lucky, lucky things. Thanks, Rasta. That's really nice of you, dude. Ah, tea's so good. All right, so let's build that. Now, I'm pretty sure that the IP addresses haven't changed. You are a legend. One day when we are free of COVID, I swear I will give you a hug. Now, this is concerning. Straight away, we haven't got this thing loaded as I would have expected. Why is that? Has our IP address changed? We're on 146.146. Maybe that's our problem. Yeah. Where is our IP address? 140. Okay, let's rebuild. And let's go again. Stupid friggin' IP. Did I mod that emote? It's the best. I agree, I love that emote. Alright, is it going to work this time? No. Why can't I connect? Have I not got an IP address on here? Yep, I do. I don't know why it's not working. Okay, let's restart MSF because, you know. Ah, that's our problem. We're going to have to vim local and change our IP. Oh no, it is 140. 140. Is it 140? Yeah, it is 140. Oh, it's 146. 146. Now, what have I got down the bottom here? Oh, that's the bind TCP, so we don't need to worry about that. Alright, let's fire that up again. Woohoo. Should launch the DB again, shouldn't I, really? Alright, let's full screen that for us. Actually, let's not. Alright, we will hopefully see a connection appear this time. There we go. Alright, so what we were expecting here, request was a get, okay, netconfig get routes. We haven't implemented that yet, so we probably should at some stage, but for now we're just going to focus on the channels. Okay, so we have a valid CLR2 on Windows Meterpreter running. Okay, so that's a good thing. Let's do the port forward thing. Sessions -1, port forward add. Never remember all of the parameters. We want to go add L. L for the local port to listen. So we'll do 8888. We're going to listen on 8888. We're going to connect to remote 9999. And the host that we're going to connect to is 192.168.146.146. Right, so that means we should have a list of channels. I guess not. Oh, I've got a call not implemented blocking. Let's just see what happens now. No? Let me just ditch that breakpoint for a sec. And we'll come back to it when I know I'm going to do something that will result in us breaking at a point that we want to break at. Okay, sorry about that. So let's kick that off again. We have another follow. Punky Brewster, thank you very much for following. It's good to have you on stream. Okay, let's quickly do this port forward thing again. Stations -1. Stations -1. Port forward add. Okay, so that's right. We don't have active channels until we do the NC thing, right? Channels, channel-L, there shouldn't be any. Right, so what we're going to do is we're going to set up our listener on 9999999 because netstat ANTP pipe rep listen should give us a listener on 9999 and MSF is listening on 888, and our port forward should connect the two via our VM. Okay, so if we go NC 192.168.146.130, no, that's a local host. We're hitting 146 on 8888. We should see some activity here. There we go. And now we should have an active channel. Right, so if we go call not implemented now, what happens when we say hi? Does that do anything? Right, we do have a call here, and as we can see, the request is core channel write. So we do need to now implement handling of core channel write functionality. Because on the wire, behind the scenes, there's going to be another TLV. So the TLVs, we have method, request channel, and channel data, which is just going to be a raw block of bytes. Okay? Does that make sense to everybody? Right, so we've got core channel, whatever it is, open. I've opened so many things. Here we go, core channel open. So we're going to need a core channel write handler. I almost knocked my tea over. I should move my cup before I actually spray it everywhere and ruin the stream. Okay, so let's implement this. We're going to do the same thing here. Oh, change that fat finger in a bit to right. Hey, Barney. That's what we're aiming for, Bitwise. Yes, we are aiming for feature parity on this new version of Meterpreter. When it comes to implementing a new feature, the aim really is to wrap that up in all of the instances of Meterpreter. So right now, the Meterp work that I'm doing behind the scenes with removing strings and adding other features, I have to do that on all the Meterps. So when this is done, this will be yet another one that needs to be updated to support those things. Hooray, huh? Alright, so we're going to return success, or basically to continue when that's done. Alright, so first of all, we need to say, okay, if we're receiving a channel write request, we need to find the channel that we're looking for, right? So let's get a reference to the channel if we can find one. Okay, we're going to do the if this.activechannels.try_get_value. We're going to read response. Actually, we should probably var it up here. So we need the channel identifier, which is going to come out of the packet. So request.tlvs, tlv type.channel ID. We're going to get the first one and value as dword. Oops, value as dword. So we're going to read that as a dword because that's effectively what it is. And then here we're going to say try get value channel ID out channel. So if we manage to find, I should put the right value in. If we do manage to find it, we want to dispatch that to the handler, right? We can go channel.write, and we're just going to pass in the data. Okay, so we found the channel. We're just going to pipe the value straight off to the write functionality. But in order to do that, we aren't going to actually pull any information out of the packets. We're just going to delegate the responsibility of handling that to the channel itself. So channels will need to have a write function on them. So we're going to pass in the request packet and the response packet. And the result of that will be whatever that write function gives us. So it's going to have a slightly different interface. We're always going to assume that we are handling this. Is this blocking? It's not blocking, correct. Yes, you are following well. Hey, Will, how you going? All right, so let's go and implement a function called write on the channel. Now that's going to be, we'll make it public, and we're going to make it abstract because this doesn't really make sense, or does it necessarily make sense? I don't think it makes sense to actually have a default write. Maybe it does, but we might come back to that, right? So we know that the channel is being implemented in standard API, channel TCP client channel. So see how this is now underlined in red? We can say, please implement the extra feature of the abstract class. So here you can see, this is where we're going to handle writing to our own TCP socket, which we currently aren't really doing anything with. Okay, so what we're going to do, we're literally just going to shuffle the data from our current thing, our current packet, straight out to the socket. It's literally just a shuffle back and forth, right? Okay, so we're going to grab the data out, which is going to be request.tlv's tlv type.channel data. So we expect there to be channel data on here, and this is going to be a value as raw, which is just an array of bytes. Okay, so you can see the data is an array of bytes. Now we have a socket, and what we should do is fire this write asynchronously. So we should go TCP client dot, where are we? Write, is there a write TCP client dot send? We need to send it on the stream itself, right? That's what we need to do. There's a get stream dot begin write. Now it's pretty important that we actually do this stuff correctly, right? Because we want to do that asynchronously so that we can just return the result. We're trying to do our communications asynchronously anyway. So hopefully that means that we will have the means to handle reading and writing on the TCP channel just using async results, and using those async results to cancel back and forth, which should make it a little bit easier for us to manage things that are going on across threads. So rather than maybe having this get stream here, let's do this. We'll go this dot, we'll just call it stream equals TCP client dot get stream. And we know that's a network stream, so we'll just initialize that as a read-only field. Now, each one of these puppies here, now remember, we're not handling flags or anything like this at the moment, so let's just default to some sensible stuff. 0. I don't like to leave things uninitialized. So that means down here we can literally go like this. This dot stream dot begin write. Okay, begins an asynchronous write to a string. So we're going to pass in the data from 0, data.length. You'll see there's this async callback, right? And it says the system async callback delegate that is executed when network stream.begin write completes. Now, we don't necessarily want to handle the case where it completes, but we probably should look into what that actually means. So let's have a look at the documentation for network stream begin write. Begin write, because we want to make sure we're doing the async thing correctly, right? Righto. So there's executed when this completes. Now, I wonder if we can actually pass in null here. Let's just have a look at some of the remarks. So we could have I/O exceptions when the socket is closed, so it's probably important to handle that. There was a failure writing to the network, an error occurred when accessing. So, new async callback, network stream async send receive, am I right, callback? Okay, so starts an asynchronous send on the remote host, to the remote host, by calling the begin write method gives you the ability to send data within a separate execution thread. So that's fine. You must create a callback method that implements this, and then pass it to the begin write method. At the very minimum, your state parameter must contain the network stream. If your callback needs more information, you can create a small class or structure to hold the network stream. Another required information, pass a structure or class. Okay, so we can do that. Your callback method should implement the end write method. For when your application calls begin write, the system uses a separate thread to execute. Okay, so that's fine. That makes perfect sense. So what we're going to do then is we need to have, actually let's have a look at that, that callback. So this async callback signature is what we need. Okay, so it takes an async result. Well, let's have a look at what the example is here. There'll be a async result. The following method is called when asynchronous operation completes, etc. Okay. So that's nothing too difficult. We just need one of these, basically. So let's just terminate that for a sec. We're going to go private void. Is it void? Yeah. We're just going to say socket write completed. Okay. So let's just quickly include the. What have I fat fingered there? Okay, we got the async result. So we should probably check the result. Async state, wait, handle, completed synchronously is completed. Gets a value that indicates where the asynchronous operation has completed. Okay. I don't know whether or not we should be using the async issues already handled when you have to build it from scratch as well. Yes. So what we should do is maybe look at an example for this thing in particular. So we'll go example. Let's have a quick squiz at some of these to see how other people are implementing this stuff. Begin write. So begin write data length async callback, write callback, passing in no state whatsoever. And then where is the handler? Come on. Show me where the write callback is. I don't see write callback anywhere. Write header. Yep, none of those are useful. Excellent. Well done. Asynchronous pattern techniques. Network stream begin write. It's got to be a good example here just to show what people are actually doing. Ah, here we go. Process, receive results. Bytes read. So that's when you call end. Okay, so I'm pretty sure that what we need to do here is go and async result is the stream on the state. Okay, so we can say, we can make that static, and we can say our TCP client channel equals TCP client channel result dot, there should be async state. So we're going to pass ourselves in. So we're going to say socket write completed is our callback, and the state that we're passing in is ourselves. And then we're just going to return packet result dot success. Now later on, what we're going to do, handle exceptions, and then we may return a different result. Okay, get a user defined object. You cannot implicitly convert system TCP client to. Oh, is that what that async state is? No. TCP client channel. Oops. Okay. So that gives us our channel, and then what we can do is we can say channel.stream.end write, and we need to give it the async result. So that's when we finish all the things. Now, according to what they're doing here, process receive results. So here you can determine a bunch of other bits and pieces. So we'll worry about that when we do our reading. Let's have a look at what they've got here. Oh, they're doing managed C++. Ooh, Satch. Begin send. Async socket operations, whatever. That's not particularly helpful. Give me code examples. So what we need to do here is put a try-catch handler around this, because things may actually fail. But that's all good. As soon as we finished writing to the TCP stream, we should basically be done at this point. Reading is going to be a completely different story though. Alright, so what I want to do, just for the sake of testing, is we're going to stick a breakpoint here, we're going to build, and we're going to go through the process of setting up this thing again. Okay, so let's kick off NC. We've still got our listener ready to go. Has anyone got any questions? Sessions -1. Set up the port forward. Let's say we want to encrypt that connection. The implementation of this has to be in these methods. Okay, have a think about your question there, Bitwise. Our comms is already encrypted. What we're doing here is we're passing data, we're port forwarding. We're literally shuffling data from one spot to another. It is not our responsibility to encrypt that traffic. It is the responsibility of the protocol we're tunneling to implement that traffic. So here we're just using NC, right? So NC is unencrypted. But we're doing a port forward. We could port forward to port 443 and do a web request if we wanted to. And once this is done, that's exactly what we're going to do. Once I've got NC working and we can see the data going back and forth, what I want to do is make a web request just using curl, and we'll see that it should just work. And we'll use HTTPS because that is encrypted comms, and the data that's going through Meterpreter will be encrypted. But we're not analyzing the data anyway, we're just taking the information that's coming out of Metasploit and sending it straight down the wire. Okay? Does that make sense? Correct. We are not even the messenger. I suppose we are the messenger. We are just delivering what it is that we're being given. They're saying, please send this information over there. That's all we're doing. Okay? NC. So we're connected, hopefully. Oop, cool. Breakpoints again. Should turn that off. Hopefully that hasn't busted anything. Okay, so channel. We have a channel. And when we type hi, what do we get? We've got some data. The data has 3 bytes, HI and new line. That's pretty cool. And we're just going to send it straight away asynchronously. And that's completed. And there it is. It's appeared. We still got breakpoints. I guess not. Okay, so we got our first packet across. Hello. Hello, Joe. So clearly there's something not quite right here because I'm sending more data, but for some reason, nothing's coming through. Okay, so let's run that again. Why is it that we're not seeing any data? Ooh, the stream was freed prematurely. So there's other stuff going on here, right? So this is interesting. Maybe it's waiting for the response. Well, as far as a response goes, that's again asynchronous. So we need to have like a read thing behind the scenes. I have a premature problem. You do? Okay, excellent. Well played. Fair play to you, boy. Fair play to you. Okay, so let's do this all again. Sessions -1. Set up the port forward. Set up the NC. Hello, this is a large message in one go. Will it work? I hope so. Ooh, look at that. And it's still going. How cool. How cool is that? So we've clearly got something going on. So maybe when we end right, we need to kind of, maybe we have to flush the socket or something like that. So let's go back to our documentation. We're making progress, at least. Okay, so when we begin right, your callback method should implement the end right method. When your application calls begin right, the system uses a separate thread. Okay, blocks on end right until the network stream sends the number of bytes requested or throws an exception. If you want the original thread to block after you've done that, you have to call the wait one method, which we don't care about. We really don't want to block that. Call set on the callback, etc. Read and write operations can be performed simultaneously on the instance. That's exactly why we're doing what we're doing, without the need for synchronization, as long as there's one unique thread for the write and one unique thread for the read. That's fine. There will be no cross interference between read and write threads, and no synchronization is required. Okay. Chocolate acquire, good stuff. It did escalate quickly, didn't it? Yeah, so that's pretty interesting. We don't care about waiting until that's been written, I don't think. This doesn't even show all of the code. Like, the my callback method implements async callback delete and is called and the system begin write returns. Yep. There really is no decent example there. This one is to do with requesting DNS. So let's look for a better example. There's a begin right example here. Okay, let's have a squiz at that. Ooh, this is brutal. Righto, so we've got the network stream. We call begin right, callback read. We want callback for write, don't we? Begin right, callback write. Let's have a squiz. On write complete, we call end write, and then we call begin read. Well, we don't really want to do that, but clearly all they're doing there is saying end the write. They're not flushing the socket. They're not really doing anything. So I don't really think that's a problem. Clearly what they've got here is like a read, write, read, write, read, write, read, write style mechanism going on, whereas we do not. So I don't really get why that is the case. But the good thing is that the example that we've got here is on read complete, which is kind of handy, because we're going to have to do the opposite, right? We're going to be sending like channel read messages back down the other way, which we'll implement in just a minute. I just want to see if there's anything in here that's particularly exciting for us. So here you got the keep listening until you send files. This is just the standard setup. And this client handler, start read. There's really nothing special in here. Doesn't look like we're doing anything particularly stupid. So what we'll do, maybe it's just because we're debugging. Okay, what is end write? End write just returns void, right? That's all it's doing. Yeah, it returns void. Handles the end of synchronous write. Asynchronous write, sorry. And that's pretty much what we have to do. So, all right, let's do something else. So when we create our TCP client channel, we are going to straight away go into a read loop, okay? So we're going to have our own begin read. All right, that's going to be an internal function. We're going to have a private void begin read, and we're just going to keep looping over this. All right. So all we need to do here is this.stream.read begin read. We can do this asynchronously, right? So we need a buffer to read into. So let's actually have a private read only. Oops, read only. God, I can't type. We're gonna have a byte array. We're going to call that the read buffer. And when we initialize the read buffer, it's going to be a new byte. Now, how big does it need to be? I mean, how much data do you think we're going to be able to read it at once? Who knows? But for now, we're just going to start with 1024 bytes. We'll come back to that. Okay. So when we begin read, we need to say we want to read into this dot read buffer at position 0. We're going to say this dot read buffer dot length, so we can fill the array up if we want to. So what you're saying is short dot max or something, right? Maybe we can do that. Short dot max value is 32k. Should we just go int dot max value? No, that's a bit too big. uShort dot max value. There you go. There you go, Rasta Mouse. Just for you. Pretty sure you can do. You can use string builder. Yeah, but we don't need to do that either because we're just going to use a fixed size array. It's just going to be reused for subsequent reads, right? So callback is going to be socket read completed. And we're going to pass in this. So we can go private static void socket read completed iasync result. Okay, so we're going to go we'll just do the same thing here. So we get our channel, we can go channel dot string dot end read. We'll pass in the result. Bytes read equals if bytes read is greater than 0, then we want to take the bytes that are in the buffer and send that back down the neck of the caller. Okay, so this is where we're going to need the ability to construct packets out of nowhere and ship them down the neck. So we might need some kind of reference to channel manager, but you know, I'm not too sure. But either way, once we've done that, we are going to do exactly the same thing again. Begin read. So we've got this read loop thing happening. That actually needs to be channel.begin read. Okay, so what we do is when we get a read, okay, yeah, it's pretty cool, hey. So we do a read, when it completes, this happens. So as soon as we've created our client channel, we kick off the read thread, right? Begin read does this.stream begin read with all of that information. When it completes, we pop in here and we go, hey, did we get some bytes? Yes, we did get some bytes. We're going to generate a TLV packet and send it to Meterpreter. And as soon as that's done, we're going to begin reading again so that we can read the next batch of data that's coming off the wire. All the while, that is happening independently of the write. Okay. Thank you very much for the follow. Kaylin, is it Kaylin Ashley? Kaylin Ashley. Thank you very much. It's nice to have you on stream. Okay, so now what we need to do is we need to create a packet that we can send down the wire. So we need to be able to dispatch that packet somehow. So the channel itself needs some kind of reference to a channel dispatcher, right? So, sorry, a packet dispatcher. If we have a look at what happened in, where are we in Metserve? When we're actually sending packets. Hang on, is there a send packet? Have we got a function called send packet? Yes, we do. So channel send packet is implemented somewhere and called from here. Dispatch packet. So this is exactly what we want to be able to call from the guts of our channels, right? So see how we've got the plugin manager has a reference to the dispatch packet. So we're probably going to need to pass that down. Dispatch packet. We're going to need to pass that down to the channel manager as well, right? Actually, that's not how we... Just the Memento. Command handler. Okay, so we've got the command handler. The channel manager needs this .dispatch packet as well. Alright, so let's go to the definition of that. Actually, we need to go to the definition of this. Okay, so there's the packet dispatcher. We need to put this in here. And we need to initialize a field on the packet dispatcher. And we'll set that to null. Okay, so that means we also need to have some kind of callback for when we create a channel, we want the channel to be able to dispatch packets back to us, because that's ideally what channels need to be able to do. So we've got this channel creators. We've got the ability to create channels. So what we might need to do here is when we create the channel, we need to give it a reference to the packet dispatcher. So this dot packet dispatcher. Let's pass the packet dispatcher down to the handler. Okay. Now the handler takes... Ooh, that's a little bit confusing, isn't it? Is there a nicer way of doing this? There probably is, actually. So when we register all of the channel types, register channel creator. That's being called inside here. Okay. So we're passing in this create function. Yeah, okay. So what we're trying to do is find a way of associating the dispatcher routine with the actual underlying channel itself. And I think it might just make sense to be able to say we'll give you an action that takes a packet as well, even though it makes this particularly ugly, because we've got then a handler as a function that takes an action that takes a packet, which isn't that readable. But it is what it is. All right. Hopefully this will make sense to you people at the end. Okay, so the handler is a function that takes an action, takes a packet, so we also need to do it here as well. We may need to put some effort into mapping these to known types at some point, right? We might even like do the equivalent of type defing these things so it becomes very clear. This dot packet dispatcher. Okay. Effort. So you're living the crypto life. Yes, indeedy. All right, so when we create a channel object, okay, what we're going to have to do is we're going to have to force people to implement the passing of the channel down to an underlying property, right? So we're going to have a protected action that takes a packet. We're going to call it the packet dispatcher, okay? And we're going to have a get and a private set. And so in here, we're going to have a protected channel constructor, which takes an action that can handle a packet. And we'll call that packet dispatcher. Okay, so this is the only way you can construct a channel. And we're going to say this packet dispatcher equals packet dispatcher. So that means that they don't have the ability to modify that afterwards. Why do you have a question mark after the uint declaration? Oh, here, because that's a nullable int. You know about nullable values in .NET? So a uint is a primitive type, right? It's a value type. So it's got 0, 1, blah, blah, blah. But sometimes if you basically want to indicate whether something's initialized or not, like in the old days, you'd have a Boolean to say that I want this thing to indicate whether that value that's stored in that variable is legitimate, right? So in .NET, you have this notions of nullable integers, okay? So you put a question mark and you can actually set it to null. And so here you can see there's a .has value and a .value. So if it has a value or it doesn't have a value, you can do different things. So that we're using that for basically manipulating channel IDs on the fly. Okay. Righto. So now we have the ability in our TCP client channel. Now have a look at this. We're going to need to pass in the action that takes a packet. And that is packet dispatcher. This construct is getting a bit big. We'll probably refactor this a little bit. So we're going to pass that down to base and pass the packet dispatcher down so that the channel class has the reference. Okay. So here we're going to, again, we need to take the action. That is the packet, and that's the packet dispatcher. And we need to pass that down here. And now our wiring is effectively complete because now we want to go and create a new packet that we're going to be sending back, right? In Java, I'd use the integer class instead of int. Yeah, exactly. Opens a unboxing pane. Yeah, and therein lies the problem, right? But this kind of manages all that for you. It basically wraps it up in a struct, which is still a value type that has a bool alongside the value behind the scenes. Nothing particularly special. So that tells us how many bytes were read. So we know that we can write a certain amount of data to the packet, right? So we need a packet. Equals new packet. Can we create a packet this way? What do we need to give it? I don't even remember my own API. Wasn't that interesting? New packet. Let's see how much of a pain in the ass our own API is now. Okay. So the packet needs a stream to read from and a packet encryptor. Oh, could this get any worse? Who have we got? Rams as X00, thank you very much for the follow. Yeah, I know, right? Welcome to coding. The packet encryptor may actually not necessarily need to be specified at this point, but let's have a look. Let's see what happens. I think there's a static constructor somewhere here as well, right? So when we create the packet, we create the packet based on the stream. Now, this basically means that we need to look into modifying the API that we have in place because the packet itself doesn't currently have any means to... Oh, here you go. Look, we can create one privately that has none of these things in it, but that's fine. So let's set this to... We'll leave that as is actually, and we'll go public packet. Now this has to be, it's going to be a request packet. Is there anything in particular that we should be specifying? I think Yes, 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 yes. We need, so when we create a packet going out, we need to give it the method and all of that sort of stuff. So maybe what we need to do is have a public packet, which we know is going to be a request packet, but it needs a method. And behind the scenes, we need to be able to create a request identifier. So in this case, our method will probably be like a core channel read message. Yeah, that's right. So we first of all, we need to construct ourselves so that we have an array of TLVs ready to go. And then what we need to do is go this dot method equals method. Can we do that? I guess not. Well, let's create a setter as well, which basically does the same thing as this, but with the method itself. TLVs remove TLV type dot method, and we'll do the same thing here. Pass in the value, which we know is going to be a string. Okay, so now we can actually set that value as a method. Now maybe what we should do is make this private. Oops, no, not that one. This one. Okay, so with that being private, it means that this has to be set this way, which is fine. Yep. So let's get rid of this because we don't actually need that at the moment. So we know that this is going to be a request, so we actually need to create a request ID. This dot request ID. Looks like we're going to have to do the same thing here, right? We'll do a private set. Remove. Sorry, I should get my formatting correctly. This dot remove request ID, because we only want one request ID value, and we're going to make that privately settable too. And so we basically need to generate a request ID. I'm not quite sure how they're generated. I think they're just a block of bytes. So let's have a quick look at what the native implementation does, because I honestly don't know how request IDs are generated. GitHub Rapid7 Metasploit payloads. Let's have a look at native. You guys write code smooth? I don't write code smoothly. Jesus, dude, not me. Let's look at TLV type request ID. Okay, we've got a few options here. Request ID is 0. That's interesting. Get string value. So that's when we're mapping request IDs from when the thing comes in. But there's got to be an example. Let's have a look in here. There's probably something in there. Maybe what we should do is look for core channel write, because core channel write will give us an idea of how this stuff actually gets mapped. Here we go. Packet create request core channel write. That is useful. So let's have a squiz at that. Does kind of highlight that this dot is it type? Yeah, equals packet type dot request. Okay, so we're creating a request. Let's have a quick squiz at this piece of code here. So when we create the request, this is basically exactly the piece of code that we're looking for. We're not supporting the idea of compressed channels at this point. Packet transmit remote request null. So that's just adding stuff. This is interesting, right? Write to remote will create a channel write, which is exactly what we're doing. What is this? Oh yeah, that's just adding the channel ID to the packet, which we'll be able to do. We'll worry about compression later. Header, buffer, add TLV group, channel data group. So it's adding 2 TLVs in a group called data group. That's interesting. I didn't know that was a thing. It's a good job we checked. Now packet transmit, it looks, because we haven't specified a request ID, maybe packet create is doing that for us. Okay, where's it going to be? It's probably going to be in core.c, isn't it? Here it is, packet create. So when we call packet create, there's nothing in here at all that indicates anything about a request ID, which I guess in some ways makes sense. So that leads me to think that maybe packet transmit does something. Transmit response, result, packet transmit. Ooh, this is interesting. It's something, hopefully we're doing that magically behind the scenes. I'm pretty sure we are. We always add the UUID to the packet, so that's... Ah, here we go. Packet add request ID. What does that do? So if we have a request ID, then we don't do anything. Otherwise, yeah, we're just adding random text. How many? 32. 32 bytes, random text. So what we can do, we can just generate a GUID, really. How big are GUIDs? I can't remember. 42, are they? Try C# in browser. The answer to everything. Yeah, thanks for that. .NET Fiddle and try.NET. So I'm going to show you, depending on which one loads the fastest. Main. Let's do it in here. Console.write. We'll actually create a GUID. Var GUID equals GUID.new GUID. Write. And we're going to go GUID.toString and GUID.toString. Oops. Length. Oops. Run. 36. 1, 2, 3, 4. So if we strip the hyphens out, we basically get a request ID of 32. Winning. So we're going to go GUID.new GUID.toString.replace, and we're going to get rid of the dashes, and we're just going to leave it like so. Simple as that. That's cool, isn't it? Hopefully that means that we're not going to generate a GUID or an ID that has already been generated. Alright, so when we create a packet, we need to give it 2 things. No, 1 thing. Core channel write. Let's just make sure that we're doing the same thing as what the native version was doing. Where did that piece of code go? Right channel. Okay, so we create a request that is core channel write, and we need to add 2 entries to a group. We need to give it the channel ID, and we need to give it the actual chunk. Okay? Well, that's all right. We can do exactly this. All right, so we create the packet. Packet.addGroup. TLV type.channel data group. So that gives us group, and then we can go group.add TLV type.channel ID, and that's going to be channel.channel ID, and group.add. Now here's where it's going to get a little tricky, because we can specify TLV type.channel data just like what this is doing. I'm not specifying There, channel data. Oh, this is interesting, isn't it? So header.type contains both. It's got flags in it, but we're just going to use channel data for now. And we need to specify this dot read. Oh, not this. Channel dot read buffer. So that's where the data has been read. Now notice this, right? When we add to a byte array, we assume that we're going to fill it. So maybe what we need to do is have an overload. Okay, which takes, actually we don't even need to do that. We can go integer. Oh, what am I doing? Get rid of that. So we're going to say specify basically the length of the data. So we might call it size. And we're going to make it nullable so that it doesn't have to be given. And we're going to default to null. Now we're going to pass that down to here and do the same thing at the TLV level. Because the TLV, where is it? Here we go. So we're going to go int size, right? Now what we need to be able to do here is take a copy of the data that's in that array. Yeah? So, we've got the type, we've got the value. We're going to say if this dot size, not this dot size, if size dot has value. Remember, we're defaulting to null. Okay. If it has a value, we're going to do something. Otherwise, we're just going to store what was given. Okay. All right. We're going to go this dot value equals new byte size dot value. So we actually have to copy it. Array dot copy. Source array is value. Destination array is this dot value, and the length is size dot value. Okay. Object to, yeah, we can. You gotta be joking. I don't remember having this problem before. Cannot convert from object to system.array. Well, am I allowed to do that? Yeah, I am allowed to do that. No, we're not. Not at nested arrays yet. But what we need to do is go to this interface and change this int size equals null. Getting there slowly. Okay, we need to do the same for the packets. Add byte value int size equals null and pass that down to the TLV size. Okay. This byte must be a non-nullable value. We're defaulting though, right? So it should be okay. Ah. Oof. I've royally screwed myself here. UUID is definitely a raw. We pass that in. Unable to serialize. Yeah. This byte must be a non-nullable value type in order to use as parameter t. So it is non-nullable. Maybe what I should do instead of having nullable ints is like force it. No, that's not what I'm going to do. So let's instead of trying to make things look good, let's do this. Let's force a separate implementation, which I think actually makes a little bit more sense, to be honest. So let's go back down here. Let's do the copy pasting. Value int size. So then we can do this. Basically leave that previous one alone. Why is that meta type complex? Oh, okay, yeah, I think that's right. You can specify a number of them. Right, so we don't need to do this. We can just do... Don't you love this whole refactoring nonsense? It's great. Okay, so we can leave that now as is. So that's done on the TLV. We need to do the same on the packet. So let's just copy pasta. Get rid of those. Here the size is going to be specified. And we can pass that down. Righto. TLV does not implement that. Does it not? Probably doesn't. Did I muff it? Ah, yes, that's right. I've got to do the add thing as well. Copy paste. Int size. Any questions, by the way? Interesting that validate meta type group. Why is it saying that it's a group? Then you love looking at things and going, wait up a sec. Oh yeah, it's validating that we're currently a group and that we can add to that group. That makes perfect sense. Undo the last 10 minutes. It's not that bad. Alright, so that means that when we're creating all of the things back in our TCP client channel, we can specify bytes read as a parameter when passing in the read buffer, and it will take a copy. Hooray! Okay, so that means at this point we should be able to go channel.packetDispatcher and pass in the packet. Phew, was it worth it? I don't know if it was, but we'll see. Let's see what happens when we do the things. Let's set up our port forward. Set up our NC listener. Connect. We don't have any breakpoints hitting. So once we've connected... Oh, hang on. Set the listener up. There we go. Okay, so we've got a connection. We don't have anything going on here. Let's see what happens when we type hi this way. We should hopefully, here we go. We've got a read result. And the number of bytes are 3. So we create a packet, we create a group, we add the channel data. Ooh, here we go. This is interesting. What do we got here? The provided standard API plugin. Really? Let's have a look at our call stack, because that doesn't make a lot of sense to me. Okay, so the type that we gave, channel data. Yeah, channel data should be raw, right? Channel data is a raw meta type. Okay, so that should be okay. Validation. Pff, who needs it? I mean, come on. Expecting meta type. Met core proto meta type array. Really? Expected types contains raw and complex. So it can be raw, it can be complex. So expected types as raw and complex, and this dot type is any? What? Standard API plugin system dot byte. That doesn't make sense. Maybe the reason for that is because when we're creating... Where are we? I may have missed something when we added support for adding this of a certain size. Yep. We've got to do the type. How did I miss that? Missed the type. Nekutsi, hello. Quick Q, yes, if you don't mind. Do you have an idea how one would get battery level from a Corsair? Mate, I'm afraid I wouldn't have a clue. Maybe some other people on stream? Yeah, look, if it were me, I would keep your experience with Java to a minimum and try something else, but I know that's not very helpful. Look, I wish I could help you, but I'm afraid I have literally no experience doing anything that you're doing. I haven't interfaced with IQ at all. It would be interesting though, because I mean, Java would have an interface that would allow you to do things like IOCTLs and whatnot. So I'm sure IQ has drivers that you can query through ioctls. I assume you're talking about on Windows. I don't know. Maybe there's an abstraction in Java that will allow you to do that across operating systems. But yeah, I'm sorry, mate. I am of no use to you whatsoever there. Yeah, IOCTLs. I'm assuming that the IQ has IOCTLs behind the scenes. Yeah. Yeah, IQ drivers are a goldmine, aren't they? Yeah, good luck, mate. Sorry, I'm not very useful to you there. Set up our listener. Establish our connection. Type hi there. And follow the bouncing ball. It goes to show that our validation... Yeah, no worries, mate. Good luck. Goes to show that validation, throwing exceptions at those points, probably would have stopped us from having an issue. Here we go. Dispatch the packet. Send the packet. And what do we get? Nothing. Thank you for the follow, Alkeus. I'm just going to stop this for a sec. And I'm just going to put this here. I'm going to run it again, because I actually want to see that go across the wire. And we might actually put some debugging in the Metasploit side so that we can see whether or not that packet is actually coming in or not. But yeah, let's see what happens. Let's see. Sessions, port forward. Really? Yeah, exit. Exit! Exit all the things. Let's do this again. Okay. Let's do things in the right order. Bind failed address is already in use. So this is a classic Rubyism. Doesn't free up sockets in certain scenarios. So let's just restart all the things. Take a copy of this, because it probably won't appear in my history anymore. And let's go again. There we go. And see. Hello there. Packet dispatcher. So we have converted our packet to a packet of a certain size. So there's stuff in it. Send. So the response, it's not necessarily a response packet, is it? It's just a packet, so I might rename that. So we write that to the stream and go. So we should actually see stuff up here. So we should probably check to see why that actually isn't happening. Maybe it's because we aren't wiring things in properly. Channel-L. So we still have a TCP client, but that should be open to receiving data on the other side and NC coming through. I mean, things are working that way, although I'm not really sure why we're seeing that repeat, which we'll come back to. Shark Park, thank you for the follow. It's good to have you on stream. Ooh, here we go. So that begin read thing, we need to handle the case where the socket closes. So we'll come back, once we've got this working, we'll come back and we will fix this up. Okay, so what we need to do here, maybe when we read from the channel, hang on, when we write to the channel, we need to question is, are we receiving multiple requests to write the data from Metasploit? Because if we are, then that's a problem. If we're not, then that's also a problem. Let's go back to the reading for now. To do that, we are going to go to code, Metasploit framework. Now we are looking to handle core channel writes. Core channel write. Alrighty, so this is where we're handling channel writes. Let's vim that up. Core channel write. Okay, so when we DIO, I was living this nightmare recently. Look at this. Now I'm really confused because this is looking straight away for TLV type channel data straight off the packet, not off a group. Which to me says when we are doing this, we shouldn't be adding to the group directly, we should just be adding it straight to the packet. Alright, let's try something. Let's just add it straight to the packet. Does that make sense? See ya, Wolf. Yeah, so that's pretty interesting, I think. I'm seeing a little discrepancy there in the two. See ya, Nekutsi, sorry. I'm so bad with names. Alright, let's give this a burl, as we like to say down under. Okay, let's set up our Netcat listener. Got a connection. Boom! Okay, so we don't need the group. Look at it. I love it. I love how broken that is. So we've actually got it working perfectly one way, just not the other. So the question is, do we need to, when we handle data coming in off the socket, what is it that we're failing to indicate has succeeded? Okay, we're so close. Yeah, we're so close. We're more than halfway. I believe, Bitwise, that we are more than halfway. Okay, so in this case, when we go, it'll be a core channel write. We will have like a TCP write that happens. Yeah, see how there's like this routine to write to a channel, and so what we would do, we would need to look for a TCP channel, which I don't know whether it's, are they all sitting in channel. Oh no, standard API has it, doesn't it? Interpreter source. It's not in metserve. It would be in extensions under standard API server. I don't think it's in any of these things. Be under net most likely. Hey, socket. Here we go. TCP. This would be it. TCP client write channel. So what is it? Writes data from the remote half of the channel to the established connection. This is what we're doing. All right. So we send the data down the network, and if it fails, we do some stuff. If it doesn't fail, bytes written. Isn't that interesting? Do we need to return the amount of bytes that were written? Maybe we do. Let's have a look at what the... Let's see what Python Meterpreter does. Core channel write, request parts extend channel ID. Here you go, channel data. So you got to specify the length. Really? That doesn't make sense. Because when you specify a raw, the length is in the header, so I'm not going to bother doing that. Forzio, hello. Welcome to the stream. It's a great question. Oops. Yeah, go away. Somehow I managed to invoke the Xbox console on my desktop. Let's go core channel write again. Okay, so when we write, we get the channel ID, get reference to the channel, make sure it's alive, and we write. And it returns a response. Core write. Okay, let's see what core write can be set to. It's a little easier to understand what the Python version is doing. Okay. Core write, we get the data. Okay, so we do return how many bytes were written. Okay, so there we go. There's our answer. Thank you, Spencer. So here's the interesting thing, right? Because when we call write, we call begin write and pass the information down the neck. But what we probably should do, which we can't do in this context, should we do this synchronously? We probably should. Because in our case, with our asynchronous reading on the socket, we're literally just going end. We don't really know how many bytes were written. So what we should do here, instead of using begin, maybe we can just go this.stream.write. And we'll give it... where are we? We're going to give it the data. 0 data.length. Okay, and that could/should throw an exception if things don't go well, right? So let's look at the network stream documentation just quickly. We've still got it here somewhere. Did I close it? Network stream, here it is. So we've got begin, etc. If we just go write, this one here is the one that we're using. What can it do? Argument out of range, invalid operation, IO exception, object disposed exception. Okay, so what we should probably do then is this. We should just try to do the thing. And if it works, great. If it doesn't, we'll just go return packet result dot. We should probably give it something other than this. Let's just go in to add a proper result. We'll fix that in just a minute. So what we want to be able to do is go response.add tlv type.length. That's what it's looking for. and we need to give it data.length. That's what it's expecting on the other side. Yeah. Now, given that we're actually doing this stuff on a thread, we don't need to do the thread again. So that might actually be overkill, but this is definitely not overkill with the reading asynchronously. That is exactly what we need to manage. But obviously we need to do some correct management of exceptions on that second thread, otherwise things go bad. All right, let's try that again. I think we're going to completely disable breakpoints, and we're just going to run them. So, sessions -1, let's set up our port forward. Hopefully we're going to see it work both ways. Works like a charm, but this does not. Okay, so hello Mike. Hello Joe. Well, there you go. Isn't that cool? So we have async communication working. What we should do, yeah, how cool is that? That worked like a ripping charm. It looks like there is actually something that I wasn't aware of in the Metasploit side, is there's actually replay semantics in cases where the data hasn't been sent completely. So, sweet. So are there any Erlang fans out there who get my reference? The hello Mike, hello Joe? No? Hello Robert? You guys need to go and watch that. Feels like a cop-out not doing async both ways. Well, we actually are doing async both ways. Remember? We've literally spun up a read thread for the TCP client. That's async because it's on a separate thread. This is a blocking send on a separate thread. Who's Mike? Go and Google Erlang the movie. In fact, I'm going to Google it for you now, and I'm going to put it in the chat because it is such a fantastic video. And in the movie, here we go, Erlang the movie. There we go. You probably heard that in the background. Go watch that movie. Unfortunately, there are 3 people in that, and one of them is no longer with us, and that's Joe Armstrong. Dude was a legend. So go watch that. That technology is U-Butte. Okay. Sorry, where did we get to? Yeah. So okay, let's do something funky, Shamon. Instead, let's just kill the session off because that makes all of this stuff significantly easier. Let's go and find. Where are we? Let's go and look for a website. What's that? Is it HTTP get? What is that? What is that website that echoes the stuff that you give it? httpbin.org. httpbin.org. Not secure. Excellent. All right. So what we can do, right, when we curl this thing, httpbin.org, we can just give it like get parameters. Okay, so x equals y, and it should return. Hang on a second. Hang on just a minute. Got to look at the docs. I got to call get at the end. There you go. So you can see it returns basically what you give it. args is y, user agent, blah blah blah. Okay, this is really cool. Oh, dude, Matt Herbs. I love Matt Herbs. Matt Herbs is a very dear friend of mine. Matt, Erlang hot code reload for the win. Amen. Amen. All right, so what we're going to do is I'm going to set up a port forward that we can curl to. Okay, so let's see if this actually works. I'm going to curl it, and then we're going to browse to it. Okay. Okay, so let's kick off a session. Now we're going to have to set up a port forward directly to that location, right? So let's go host http bin.org. So if we curl this address, do we get the same thing? Yes, we do. All right, so let's do the port forward thing. We're going to listen on port 88888, but we're going to pass off to port 80, like so. So now if we curl to our local host, http 192.168.146.146, right? We're going via port 8888. So here's what's going on, just to be very clear. Hacksighting, thank you for the follow. This curl request is connecting to this local listener, right? The local listener will go and connect out to our running instance of Meterpreter, which will make a request outbound to this address that we've pointed to and should allow for traffic to go back and forth. Fingers crossed that it works. And there it is. Look at that. So that web request has just gone through our Meterpreter. How cool is that? That's cool. I think that's cool. Don't you think that's cool? So that proves that we really don't give a hoot about the traffic that's going behind the scenes. And check this out. See how the URL was what we pointed at locally? That's pretty funny, huh? I'm leaking IP addresses. That's a bit rough. There's not much I can do about that. I don't really care. Hack me. So yeah, that is a win. Our port forward at least appears to be working. Now, obviously, we haven't finished supporting all of the nuances of a TCP client socket at this point, but legit, it's working. So here's one thing that we need to do. Like, we want to be able to kill off the port forward now, right? So in order to do that, where was that call not supported thing? It was in, which one was it? Serve? Where was it? Can't remember where it was. Oh no, it was in the packet, the plugin manager, right? Call not implemented. So what I'm going to do is kill the port forward off. Port forward should show. Port forward remove 1. I was not expecting that. I was expecting a call to kill off the channel. Ah, here we go. That took its sweet AS time, didn't it? So what do we got here? This is a core channel EOF. So why is it that we're getting an EOF? And I was expecting a close. Like EOF, that's actually used as a bit of a heartbeat behind the scenes. But I don't understand why we haven't received a channel close message. Ah, yes, okay. That would... Actually, I think I do know. Because core channel close would close when the socket's connected on the other side. So we didn't actually do it the way that I would expect. So we need to handle core channel close in the channel manager. Okay, so we've got write. That's going that way. We will implement read when we're going the other way. Core channel close. So here's what I'm going to do. Need to create a private inline processing result core channel close. So, is everyone following along? Is what I'm doing making sense? This is important. You guys, actually we should the whole thing. Ah, really? Yank. Paste. There we go. Okay, so what we need to do is we need to pull out the channel, and then we need to close the channel. So let's just handle that for a minute. This would be packet result dot success. Channel dot close. So we want to close the channel off, and then we want to go this dot active channels dot remove, and we can give it the key, which is the channel ID. So we no longer care about that channel. Now the closing of the channel needs to be abstract as well. So let's go to the channel definition for right. Now, do we really care about, like when we receive a core channel close message, I don't think it actually cares about like handling the request and response. So I'm just going to void. I'm literally going to say, just close your channel off, do your thing, and we're good. All right. Let's go back to the TCP client channel and ask it to put a stub in place for us. All right, so what I'm going to do now, when we close, we're going to go this.tcpclient.close. Right? Now, what should happen is that this begin read, okay, because that should be sitting there raring to go, will result in an exception being thrown when we have the socket read completed. So I would assume that there's going to be an exception either here or here when we close, given that that's still open. And that's the mechanism that we need in place to properly handle the closing of the channels and making sure that we don't crash just because we haven't handled exceptions properly. So it's kind of exception-oriented programming in this regard, but it is important. So what we'll do is we'll set a breakpoint, not there. Stop. Set a breakpoint there. Build. And let's go back. And what we'll do is we'll set up our port forward like we did before, but not with curl. We'll do the NC thing. Okay. So NC, and we'll NC as the client. And this should all work perfectly, right? Hi there, how goes? Great, bye. And now when I press Control C, here we go. We are closing the channel. All right, so we go into channel close, and this is where I'm expecting to see an exception somewhere. So here we go. Socket read complete, end read results in a network stream being closed. All right. Now, here's the thing that we need to make sure that we sort of free ourselves up when the end read fails, right? So we need to effectively do this. We need to try, and we need to catch the exception. Now, the exception from end read that indicates that the socket's been closed kind of doesn't really matter to us. We don't really care what the exception is. We're just going to assume that the channel is currently closing. Now, there could be other reasons why end read would fail, but at this stage, I think it's fair to say that if this fails, we just don't. Well, obviously, we don't want to kick off the begin read again. We just basically want to say, okay, we're done. We're not going to continue doing the asynchronous result processing. Now, here's an important thing, though, that when we close the client, we should probably dispose of it as well, does it? Oh, no, we don't need to dispose that. Closing actually disposes of the underlying stream, right? Request the underlying TCP connection be closed. So this should be enough. I know it's a bit of a Pokemon pattern because we're just saying, can we please do this? And we're not really worried about the exception that gets thrown, but I think that's okay. we could do this. Catch exception E system.diagnostics dot no, not diagnostics, debug dot. What am I doing? Oh no, it is diagnostics dot debug. Debug dot write line. Let's just, for the sake of debugging, we want to put this in. We're going to go and we're going to say TCP client. I can't type. Channel exception ex.mess ex.message. Oh no, I can't do that. I've got to go string.format, don't I? E.message string.format. There we go. So we can actually see it appear. So let's build that. We're going to be running it under the debugger, so we'll see it when it happens. Sessions -1. Set up the port forward. Set up the listener. Set up the connection. Do a thing. Kill the connection. Aha, now notice that. Did you notice that? See how like the server has killed the connection, but we still think it's alive. I don't know what's actually happened there. We don't have any output, do we? Yes, we do. Here we go. TCP client channel exception. Unable to read the data from the transport connection. Established connection was aborted by the software and your host machine. That's very interesting. So here is the underlying thing. What we should do is have a private bool closing equals false. Okay. So what we want to do is go this.closing is true. Now, here's an interesting thing, right? If this.closing, because if we're closing, sorry, channel.closing. Okay? If we're closing, then we know that what we need to do at this point is, see you, Barney. Yeah, catch them all. Bitwise, no, we can't use the using here because the scope is beyond the scope of a single function. Anyway, so if the channel's closing, then that's expected behavior, right? If it's not closing, that's unexpected behavior because we haven't called close. Yeah? Yeah, no worries, mate. So what we need to do here is we need to tell the other end of the connection that the channel has closed. Okay? That's what I'm assuming. And if we have a look at, again, the implementation of... Let's look at the Python version again because I think it's a little easier to digest. Just got to find it. Here we go. Righto. So if we go core channel close. So this is handle dead resource channel. So we remove the channel and then we send a packet of core channel close and we're done. All right, so what we need to do is we need to set up. Thank you for the follow, Aki Vaishli. Sorry if I said that in a very poor way. So what we need to do here, this is a case where we basically need to tell the channel manager, hey, like we're done, and you should kill us. Thank you very much. So what we can do is when we create the channel, we can basically say, hey, I'm interested in when things go bad. Right? So if on the channel itself we have an event, You guys know how to use events? It's been a long time since I've used events. Hang on. .NET C# event example. This is how long it's been. I don't remember how to use events. How to raise and consume events. That sounds good. So from memory, like we create an event instance locally and we expose that through a property that people can subscribe to. Okay, so let's have a squiz. What do we got here? Event handler. Yep, here we go. So this is what we're talking about, right? Now we can create our own event, but I don't think that's absolutely necessary. So we're going to have a public event. Sorry, lowercase event handler. And we're going to call, hang on, what is the syntax? Threshold reached. So we're going to have a channel closed event. Okay. And that, because it's public, can be subscribed to by the channel manager. So when we create an instance of the channel open, we create a new channel, we add the active channels to our list. We're also going to do this. New channel dot channel closed plus equals, we'll just define a new thing for ourselves. We'll just call it channel closed because I don't like the things that are associated with that. Now the object / sender, we know that's going to be the channel. Now what we need to be able to do is probably pass up some information that has to be put in the packet, but who knows. For now, what we'll do is we'll delegate the responsibility of that to the channel manager itself. Okay, so that means we can basically create a packet equals new packet, and we've got to give it a core channel close. Okay, packet.add tlv type.channel ID, and we need to give it the channel is going to be a channel. So the sender will actually be a channel. Okay, so we can take the channel ID straight out of the channel. Channel ID. And we can, this.packet dispatcher, we can dispatch that packet out on the wire straight away because that's pretty much all we need to do. The request ID will be added for us. And then from here, we just need to this.activeChannels.remove channel.channel ID. Okay, so this happens in the case where the channel's closed on the server side and we need to do the accounting to keep ourselves tidy at this end. And that will hopefully let us know that things at the other end have failed. Okay, what do we got here? Channel. That's correct, it's never used. Okay, so what we're saying here by our TCP client channel, right, is if we're not closing, then something went wrong, okay? And we need to, we basically go, we're going to close ourselves. That's something we're going to do. And we need to go channel.close. And we also need to do effectively the event handling thing. Now, this is really interesting, right? You'll see in this example, we've got this event handler equals, and we assign a copy of the threshold reached locally. So this is our public reference, and we assign it locally, and then we check the local reference for null. And the important thing here is that the handler, what you can end up with is like threshold reached can be null. So when someone hasn't subscribed, then threshold reached in this scenario would be null. Okay, so you could go if threshold reached is not null, then call the handler. But the problem is that in a threaded scenario, there's a risk that you can go threshold reached is not null. Yep, great. But threshold reached then gets unsubscribed to later and becomes null. And when you call threshold reached this E, clearly it doesn't do what we want it to do. It will end up crashing because threshold reached is null. So this is what you do to indicate. This is how you fire an event to make in a thread safe manner. So we're going to go private void fire closed event. Okay. So we have a event. So we don't even need to go var handler equals this dot. Actually, we can even call base dot channel closed. Okay. If handler doesn't equal null, is that right? Am I doing that right? Threshold reached event handler. This event can only appear on the left-hand side. What am I doing wrong? Public event handler, channel closed. I don't know why that's not allowed. I don't think that will make the difference. You see here, we're doing the same thing. Maybe we need to call this by a specific type. No? So this is effectively what we're trying to do, is we go handler this new event args, and we don't need to give any event args at all. Delegate invocation can be simplified. Ah, I didn't know that was a thing. Wow, that's new to me. How good is that? This event can only appear on the left-hand side of a plus equals except when used from within the type. Okay, so that's a problem. So then what we can do is put it in here. And then in here, sorry, that needs to be protected so that subclasses can reach it. And we'll put this, oops, we'll put this down near the bottom with the rest of the protected stuff. That makes sense to me now. So you can only refer to events in that context when you're doing it from within the type. Okay, so we need to go fire base dot channel dot fire closed event. Okay, so that says inform the management utilities that the closed event has been fired, and then close the channel. I think that's fair. We leave that to ourselves to clean up rather than the manager. Does that make sense? Getting pretty close to the end of the stream. It looks like we're going to hit pretty much exactly what I was hoping to hit and actually have the mechanism functioning. We obviously need to provide support for other types like streaming channels and things like that. I'm not quite sure what those semantics mean at this point, but our port forwards appear to be working, which is kind of exciting. So we're going to set a breakpoint here. Sessions -1. Set up our listener. Let's set up our port forward. Connect. Prove that it works. Cancel it. And that didn't do anything. I am lost. Why did that not work? Why didn't that work? I would have expected this. Okay, I'm confused by that. I would have expected one of these to fail. I would have expected this end read to fail. Because we aren't actually closing, unless there was some other mechanism going on there that I wasn't familiar with. Right, so we know we're functioning. We know things are doing what we want. I'm going to kill this off. Well, there is no failure. Why? Is it because we're getting hit here? We shouldn't be getting a hit here either. There is exited with code 0. Now, correct me if I'm wrong. That's not the behavior we were seeing before. Right? Am I going mad? Oops. I have no idea what's just happened. Sorry about that. Okay, there we go. Back to normal. Sessions -1. Set up the port forward. Set up the listener. Set up the client. Is anyone else confused or is it just me? Confused. Yeah, why are we not seeing a breakpoint? Like, end read should die. We should see this thing being hit, right? This is all working beautifully. Cancel. Why you no break? It still thinks it's there because we haven't closed it. Why hasn't it broken? Try to set a breakpoint before the catch. Well, the point is that this should throw an exception and get caught and hit here. We're not seeing any of it. So we're still getting rights. Ah, here we go. So that actually died, but for some reason... That's bizarre. So anyway, this is not closing, so it should fire the closed event, which results in that getting invoked. And that's it, just trying to write. Okay, so we're going across threads a little bit here, which is a bit confusing. Packet dispatcher, so we send a close at that point and we ditch the channel and we close. So at least we're not breaking and at least there's no channels left. Kezor6, thank you for following. Yeah, so that confuses me because I would have thought that when I killed the socket at this side that the begin read fails. That the end read fails. Because this call has already completed, right? We set a breakpoint here and we'll prove it. So, set up the listener again, connect. See that? Begin read. That's now running. Okay? When I kill the connection this side, oh, why have we got another begin read call? That's very strange. Wow, here we go. Isn't this interesting? This is interesting to me because end read, I would have thought, should have buffed. So that's why we're not seeing it. Okay, let's quickly go back to the documentation. Where are we? End read. Okay, so exceptions. Underlying sockets closed, object disposed. Number of bytes read from the network stream. completes an asynchronous read operation and begin read. Before calling, you should do the usual shenanigans. The nRead method reads as much data as available up to the number of bytes specified in the size parameter of the begin read method, which we have specified as, you know, short.maxValue or unsigned short.maxValue. If the remote host shuts down the socket connection and all available data has been received, the nRead method completes and immediately returns 0 bytes. There we go. Okay, so that explains things. So we need to connection closed equals false. Right? So what we need to do here is we need to remove this call here, and we need to remove other bits and pieces here. Righto, because we need to do, when bytes read is 0, connection closed is true. Okay? And then we don't do this, we need to do that later. Okay? So, connection closed is true. So then we need to go if connection closed, then do the things that we were doing before. Otherwise, the connection hasn't been closed, we'll just repeat. Yeah? So connection closed can happen when an exception is caught and when we receive 0 bytes off the wire. Alright, let's try that. Kazor 6, let's do the what thing for you. There's a brief explanation, and currently we're implementing channels over our, that's clear, over our transport, over our implementation. Righto, so this is the final hurrah because I'd like to see the sockets close correctly. In both directions. So let's set up that port forward. Set up the listener. Connect. Okay, so that works. When I kill the server, channel-L, no channels. Okay, so that's good. No, it's not like Caldera at all, mate. It is a CLR implementation of Meterpreter, and Meterpreter is just, it's the well-known wrap that comes with Metasploit. We're building a new version of it that runs native to .NET. That's basically what we're doing. So, yeah, Caldera is a very different beast. Okay, so that did what we wanted. Let's do it again here. Now what would be nice is if Metasploit actually informed the client. There you go, it's working. It's doing exactly what we want it to do. With all of the Shizen being correctly cleaned up, I would assume. Let's just make sure that we get the channel closed event in both scenarios. Pardon me. Actually, what would be interesting is, oh no, if we're closing from the other side, then this channel closed event should not fire. Because, yeah, okay, let's just make sure that that is a thing. Okay, so if we exit from the client side, there should be no channel closed event raised. Good, there isn't. However, if this happens, and we do it from the server side, we should see it. There we go. All right. That's exactly what we wanted to see. See, so this is sitting there hanging because Metasploit hasn't told this socket that it's closed. Anyway, it looks like we have the basic building blocks in place that allow for asynchronous comms to happen successfully on a TCP client socket. And I think enhancing the abstraction from here to work with server sockets will be pretty easy. But before we do that, we should go through and make sure that we handle all of the other configuration options that appear to be in the flags. And those flags would be whether something's compressed or, you know, all of that sort of stuff. So anyway, I think that is a perfect place to stop for tonight's stream. What do you guys and gals think? I think we had a fairly productive session there, and I'm hoping that you guys learned something. I did. Thank you, Rasa. It was good to see it all come together. It's nice to see a port forward actually functioning as we want it. It's pretty cool when you actually get that channelization working. It's pretty nifty, I think. But I think now that we've got the basic building blocks of that channeling kind of infrastructure in place, I reckon flicking it over to the server will be easy, and adding abstractions over the top of other channel types won't be that difficult either. So, Trey Puntini, I will do the bang what thing for you again. Oops, I would do the bang what thing for you again if my keyboard wasn't mucking around. That's what we're doing. Thanks, Multi. Thanks to everyone again who has participated in the chats and kept me entertained. Playtime is indeed over. It is time to go home. Is this another Beat Saber tune? Pretty sure it is. So yeah, look, I really enjoyed that. It's good to feel productive in the dev world and get some code written. I hope it wasn't too painful for you guys to witness. And if you have any questions, as always, you can hit me up now while I'm finishing off. You can hit me up on the Twits. You can hit me up on the Discords, a link of which will appear as soon as my face disappears off this stream. But yeah, always happy to help, always happy to clarify things. If you want some more justification as to why I'm doing certain things, or understanding of the old whole .NET-y bits and pieces, which clearly I'm getting back up to speed with because there are new features of it that I haven't touched myself, then yeah, we can all continue to learn together. But given that everyone is now quiet, and we've gone 10 minutes or so over the top of the intended time, I'm going to call a halt and retire as I have an early morning tomorrow. But thank you all for your participation, for your comments, for your questions, for your support. Thank you for your follows, thank you for your subs, and as always, be good to each other.